Let's go over a couple of things that we should keep in mind prior to measuring our P's and QRS's and T's. First off, we have a professional looking drawing here instead of my scribbles. And let's just go over a few things to think about, like this P wave right here. Remember that was SA to the AV. And so we should be able to assume that a P wave is going to equal atrial contraction. Does that make sense? Because we know the electrical signal went from SA to AV, so we should have gotten an atrial contraction. The second thing is this part, this what we call the QRS, this big thing. This is the QRS. That was the His-Purkinje system. His through Purkinje's. So we should be able to assume that the QRS is equal to ventricular contraction. So let's look at the two of them and see if that makes sense. The P wave is much smaller than the QRS. And this makes sense because the P wave is the atria, and the atria are about 1/3 the size of the ventricles. And they have much less tissue. That looks like what we're seeing here in this electrical diagram, because the ventricles have a much greater deflection. They must have much more tissue, and they do. The other thing to keep in mind is this section right here, from right here to right here. Apparently the signal has gone into the AV node, but it hasn't come out. When it comes out, we get this big deflection as it runs down the His-Purkinje system. So this section, it must be sitting in the AV node waiting to leave. So we have a measurement here that we'll be using called the PR interval. PR interval goes from the time the signal leaves the SA node until it leaves the AV node into the ventricle. The other thing is our T wave here. Our T wave, there's no contraction going on with the T wave. Remember, that's just the movement of ions back to the starting point. We call that repolarization. There's no contraction involved in that. The other thing to keep in mind is if you were feeling your pulse, say down at the wrist or up at the neck, this is the thing you would feel. You would feel a QRS, because that's both the right and the left ventricle working. And when you feel a pulse, you're actually feeling the output of the left ventricle, something we've been calling cardiac output.